Hi everyone, Zach here, and today's tutorial will be the first in a series of tech art tutorials that I'll be doing. We'll be covering the standard opaque material in this video. This video topic was selected by my Patreon supporters, and supporters will get early access to this video even before I have edited this video for consumption on YouTube. You too can have a voice in what content this channel covers by becoming a Patreon member. Now, before we get into this tutorial, I have two things I quickly want to address. First, this tutorial will be the first in the style that I am doing, so I am not sure what the final tutorial will look like. For example, I may decide to edit in slides to explain theories that I will discuss in this video. Second, why are we doing tech art? Well, for ages, people have asked me to cover specific topics instead of just doing a full game development tutorial series. I selected tech art topics as this is an area I have worked in professionally for a few years, both as someone doing virtual production work in Unreal and as an authorized Unreal trainer for an Epic partnered Unreal training center. So I gave my Patreon members a list of tech topics I want me to cover. This is the one they picked to start with. Okay, with that rant out of the way, let's make a start. I'll be doing this tutorial in Unreal 5.3, but you can do this in nearly any version of the engine. Alright, again, as I said, let's make a start. So, for this video, I've already set up a very simple project. We have a root folder called tutorials within content, and in here we have levels, which contains this map, and meshes, which contains this mesh right here. On this sort of map where I'll be testing my materials, I like to have a color calibration cube. This is useful for making sure the colors are right, testing in different lightings and different environments. Where can you find this cube? Well, you can find it in your engine content, and then once you're in there, you can search for color cal, and you'll find your color calibration mesh in there. Now, if you can't see your engine content, what you do is in your content browser or content drawer, click settings and go to show engine content. Likewise, this mesh, which is our SM matte preview mesh, so material preview mesh, if I type in matte preview, you'll find it. Now I have copied this and made a version of it in my meshes folder here. And finally, I have a little cube that I can apply on my materials too, just useful. All right, next, in the description, you will see a link for a zip file. Go ahead and download that link. That link contains the textures we'll be using in this video. Now, really quickly, I want to address a topic. One of the issues I often ran into when I first started out working in Unreal and looking at materials is everyone approaches their materials in different ways. Sometimes, for example, people do not channel pack materials and leave all the channel and use all the textures they can. And in some cases, people channel pack. And that can make working with a material really hard. And that can make working with different texture types really hard. So one of the goals with this material is to be able to work with different types of standard channel packing and with non-channel packed textures. So what is channel packing? Channel packing is when you take a texture group, so say ambient occlusion, roughness, and displacement. So what is channel packing? Channel packing is when you take a texture group such as ambient occlusion, roughness, and displacement and put them in one texture together by taking the individual textures, so ambient occlusion, and putting it on the red channel, and roughness on the green channel, and displacement on the blue channel. So you're packing the texture or textures into different channels. Now, in all cases with channel packing, the most important texture gets the green channel. Why is that? Well, we use the most important on the green channel because as human eyes, we put the most important on the green channel because, well, two reasons. Human eyes are better at seeing green shades than other shades, so we get more details from that. And likewise, our computers are designed in the same way. So there's more information on the green channel. So we want to put the most important of whatever we're packing on that channel. And so the two standards we'll be working with are ORM, which stands for Ambient Occlusion, Roughness, Metallic, and ORDp, which stands for Ambient Occlusion, Roughness. You can see that roughness is the most important, and displacement. Now, sometimes, just for note, ORM is sometimes called ARM, ambient versus occlusion being the keyword you're using. And the key for channel packing to read for Patreon members, I'm actually going to be talking about that later, so I'll come back to what I was about to say. So with that out of the way, go ahead and download the textures. And in here, I'm going to create a new folder called textures. Now, in doing this, I am kind of violating a small rule. We'll talk about that in a second. You'll notice in these textures we have, they all start with T underscore. Well, that T stands for texture, so I don't really need to put it in a folder called textures. I've already said it's a texture. The reason why I'm doing it this way is just for organization. But typically in a project that I'm working on professionally, the textures, unless they're global, will be with the mesh they are related to. But for now, let's import them. And you'll notice as well, at the end of them, there's this suffix. So we have ambient occlusion, AO, diffuse, our base color, D, displacement, DP, M, metallic, NM, normal, R, roughness, and S, specular. And then here we have our two channel packed versions. We have ORDp, which again is ambient occlusion, roughness, and displacement. And then we have ORM, which is ambient occlusion, roughness, and metallic. Now, one important thing here to note is the suffixes on the channel packed are the order in which they are channel packed. So ambient occlusion in both of these is the red channel, and in both, roughness is the green channel. And then for DP, our displacement is the green channel, and for M, our metallic is, and for ORDP, our displacement texture is our blue channel, and for ORM, our metallic is put on the blue channel. That, for Patreon supporters, that's what I was going to say earlier. Okay, so now that we've imported these, let's just make sure this has converted over to a normal map. I didn't actually check the little pop-up to see it has, and yes, it is set to normal. All right, let's go ahead and save this. The next thing we're going to do is we are going to go back to our tutorials folder, and we're going to create a new folder called materials. Now, typically in projects, I split my materials in two ways. I have my masters and global functions and anything that isn't specific to a mesh or isn't an instance for that mesh in here. And then I'll have the instances or something specific for a mesh in that mesh folder. So what I'm going to do is in here, I'm going to create a new folder called masters. And we're going to have 3 folders in here at the end of the video. In masters, I'm going to create another folder called opaque. This will house our opaque master. And so let's create that new master material. So I'm going to right click, select material, and I'm going to name this M_object master. I call it objects. I think about like hero assets, objects out in the world, everything that isn't something sort of special like a reflective surface, a clear coat surface, a glass surface. I think about it just as a standard quote-unquote object. And I don't mean that in the C++ sense. Let's pop open our material. Now, I am not going to cover Now, let's take a look at our material domains. In here, we have everything set up the way we want. Now, one thing you might want to change based on what you're doing is change this from Now, one thing you might want to change based on your project needs is our shading model from default lit to subsurface. Now, I won't be covering subsurface in this video, but if you want to do subsurface scattering, just change this to subsurface and add in your subsurface information over here where it has subsurface color. And you'll also have to update your opacity as well. So outside of that, other things I want to change is I like scrolling down and making sure that I am able to work with our instance static meshes, our geometry collections, and in my virtual production work, I often use Nanite. So we'll have that with Nanite. You don't need to have that set, and you can change that down the road as you see fit. But that is where I like to get started. All right, so now that we have this set up in terms of just having a material we'll be working with, let's just save it real quick. And we're gonna pop back out of here for a second, and we are going to go back to our materials folder and create our second folder called global functions. All right, and in global functions, what we're gonna wanna do is we're gonna wanna set up some really simple functions we're gonna use for almost every material type, including the landscapes, though there will be some variations of landscapes that we'll be using. And the reason we use global functions is for a simple principle. And the reason we're using material functions is for a simple principle called DRY, which stands for do not repeat yourself. Or actually, it's don't repeat yourself. Now, doing tutorials, I will often repeat myself. But the idea here is that if you have to use the same code over and over again, you don't want to have to rewrite the code over and over again. You're not repeating yourself. Just like we do functions and recall functions in coding, we want to do the same in materials. We want to have that there to make our lives easier. Also, if we make a mistake with one of them and we then copy that elsewhere, we have to edit each material using this thing. Whereas with the material function, if we make a mistake there, yes, it affects all materials, but we only have to edit it once and all materials are in better shape. So we can reuse a material function, whereas with a material where we've just copied and pasted something in, we have to then find it again, edit it. We have to find it again. We have to edit the materials. We can make mistakes. It just becomes tedious, especially when you have a master for many different domains. Okay, so that said, let's go back to our editor and get working on our first function. So the first function we're going to do is what I call our tiling function. Now, it's not really for tiling. I have this because I use this particular function with other things. The first one we're going to create is our tiling function. Now, it's not really going to be used for tiling in the sense that, wait, no, it is. So the first one we're going to create is our tiling function. Now, we'll use this elsewhere if we do landscape, for example, to get some more functionality out of our tiling options. But for now, we're going to name this MF for material function, tiling, and I'm going to name it tiling objects. I do make some different changes when it comes to our landscape. Now, another reason I like using material functions for a lot of the simple things is that it allows me to not have crisscrossing lines in the material. So all we're going to do here is we are going to set up our UV scale. So what I mean by this is if you just create a quick texture parameter in our object master, we're setting up what we're pinning into this UV. Okay, let's just delete that for a second. And I'm going to first get a texture coordinate node. And this gives us our UV tiling. We're going to leave it default to 1 to 1, and we're going to leave it on our coordinate index of 0. Holding down the M key, I'm going to multiply this value. And I'm going to multiply this value by a UV offset. So I'm going to hold down the 2 key, even though this will convert this to a vec4 in a second. And I'm going to right click this and convert to parameter. So now we have 4 channels instead of our 2, but that's fine. I'll name it UV offset. And now if I plug this into here, we might get an error message. I'm not sure if we'll get it at this stage now. But if we went all the way through, we get an error message saying, hey, you're trying to convert a vec4 and a vec3 or a vec2. So what I'm going to do is I'm actually going to mask, and I'm going to look for component mask, and I want to have the red and green channels only. I'm going to get rid of the blue and alpha, and I'm going to plug that into our multiply here. I'm just going to select these two nodes and hit Q to make sure they're lined up. Selecting UV offset, what I'm going to do is I'm going to start organizing things, and this makes working with our instances way easier. In my group, I'm going to type in 0, 0, global. So this will show up in a material instance under a category called 0, 0, global. The next thing I'm going to do, and I'm just going to pop open the default values for a second, is I'm going to change the R to 1 and the G to 1. Now, under channel names at the bottom, I'm going to name this U for the R channel and V for the green channel, and not used for the blue and alpha. All right, that lets me know what these are that I'm editing. The next thing I'm going to do is I'm going to do another multiply, so hold down the M key again and click, plug that in, and I'm going to create a scalar parameter by holding down the S key and clicking, and I'm going to name this tiling. This will control our actual amount of tiling that we're doing, and I'm going to default this value to 1. Okay. Next, once if I want to scale the texture, once if I have a texture, say, from Quixel, and by the way, the approach we're working with will work with textures from nearly anywhere. I've used it with Quixel, I've used it with Polyhaven, I've used it with stuff I've made in Substance Designer, some stuff that my teams have made in contract projects, stuff that I've done in virtual production work. So this does work with a lot of things. And the reason why I bring this up is because sometimes, say like with Quixel, you might have different scales of textures. So one thing we can do is we can search for a material function from Unreal called scale UVs by center. All right, and I'm just gonna plug this multiply into our UVs, because remember, this is our UV setup. And then for our texture scale, we can take the same approach again, or we can do it a different way. Now, I'm going to show you the other way of doing it just so you know what your options are. I'm going to first hold down the S key and make a new scalar parameter that I'm going to call X scale, which I'll default to a value of 1. And then I'm going to do an append, and I'm going to do append vector. And I'm going to duplicate this X scale, plug it into the B, and I'm going to rename this Y scale. And I'm going to plug that into my texture scale. This will be what we're scaling it by. Now, really quickly, I skipped a step. Let's go back to tiling. And this is going to be under global as well. And same for our X and Y. Now, why is it called global? Well, this is going to affect all areas of the material, be it the base color, the roughness, the normal, all areas. It's global to the entire texture. It's not global across, sorry, it's global to the entire material. It is not global across materials, though. All right, the next thing I want to consider is once if I want to rotate a texture. Once if one texture is sideways for some reason. Well, then I'm going to take from this UVs and I'm going to do custom rotator. So this allows me to rotate the UVs based on a rotation angle and a center. So for my center, I am going to do I'm going to do 4, even though it's going to be only the 2 channels I care about. Convert this to a parameter, and this will be my rotation center. And I'm going to set my red channel to 0.5 and my green channel to 0.5 as well. I'm going to plug that into my rotation center, and this will be also global. And then for rotation angle, hold down the S key, and this will be my rotation angle. Now, this, as it notes, is a 0 to 1 scale, so I'm going to set my min to 0, my max to 1, and I'm going to leave it at 0. All right, and again, we're going to put this in the category of global. So this will be our tiling function that we'll use in our main material. Go ahead, apply, and save. So let's go back to our material then and set up our tiling. Actually, so once I've done that, the next thing I'm going to do is either select the graph or click the output node. The next thing I'm going to do is make sure that I've clicked the graph itself, and in here, I'm going to do expose to library. What this does is when I go to a material and I search for tiling object, I'll be able to see it. Otherwise, I have to right click and do material function call and find it, and that can be a hassle. If you want to put it in a category, you can click the library components or categories text and change this or add it to a second one. You can be in multiple categories. And we'll see that when we use a material function from Unreal. In fact, actually, if we search for scale UVs, these are all under miscellaneous, but we'll see it with some of the normal material functions we'll use. All right, back in our object master, what I'm going to do is I'm going to search for our tiling object. What the fuck? So back in my material, I'm going to search for tiling object, and there it is. Now, if you don't see it, but you have clicked expose to library, make sure you apply or save and apply. All right, now as I mentioned earlier, I don't like when people have lines crisscrossing all over the place, which happens a lot in materials. So this is a nifty little thing called a named reroute, and we're going to create one. Actually, we're going to go back to this really quickly, and I want to rename this output as tiling. And now I'm going to apply, save. We go back here. Well, we'll have to either refresh the node or get rid of it. We'll get rid of it, and we'll do tiling object again. And there we go. We have tiling. So this named reroute node, all I'm going to do is type in the word named and hit enter. And it gives me this node where I can type in a name. And I'm going to call this tiling. What this does is I can then search for a node called tiling. And notice this one has only a pin on the right, and this one has a pin on the left and right. The ones on the left and right are saying this is where you're naming it. The one with it just on the right is where you're calling it up. So if I double click this, it's going to take me to the original node. I can now use this in multiple locations. So we'll actually be doing that in a few different ways. But before we do anything else, let's just quickly organize this a bit by highlighting this and naming this globals tiling. Okay. Cool. We can move this off to the side for now. The next thing we need to do is we need to create a couple of functions that we'll use throughout this entire process. So back in our global functions category or folder, let's go to right click, materials, and in materials, let's search for our material function. And this material function will be our texture UV. This is where we'll actually bring the tiling into our textures. But this, again, will make things a little bit easier down the road, and you'll see how. Again, I do this on every single texture that we use. So why have the same code over and over again when I can just have the material function, and if I make a mistake, I can edit one thing to get it all working. So I'm going to hold down the T key to get a texture sample. Now, in my objects, I don't tend to change my sampler source. For landscape, for atlases, things like that, where it's going to be a bit more different. For things like landscapes, I might change it to wrap. For UV assets, it might be clamp. But I'm just going to pin this into my output really quickly. And I'm going to not rename this one. For this, we aren't going to put in a thing here. Instead, what we're going to do is we are going to pull off the texture here and do input. And it fortunately has given us a texture 2D. You might run into an issue, and I did when I first set this up for work recently, where I didn't notice it changed a value from what it should be. So this is our input node. When we call this function up, we will have a node called texture, or we'll have a node called in right now. We're going to rename this as texture. Now, that just lets us know that we're looking for a texture. If we want to put a preview in, what we can do is just do texture object, plug that into there, and you'll see we can see it now. I'm just going to make this our default black. Okay, and the other thing we need to worry about is this UVs, that thing we set up in our tiling. So to handle this, we're going to do another function input, and notice, I made a warning that this is going to be that something could be potentially wrong. Well, this is wrong. We aren't looking for a scalar parameter, we're looking for a vec2. So under input type, change it to vector2, and I'm going to name this tiling. And in neither case do I want the previews to be our default values. I always want to override whatever I put in for our default values. Again, we're going to expose this to our library because we are done with it now. And then let's go back to our object master. So if I then search for our texture UV, I can plug tiling in, I can plug a texture in, and I get a result. We're going to delete that for now because we're going to handle this first looking at our base color, or albedo. And for albedo, we're going to have something a little bit different. We're still going to use this material function, but we're going to call it up in another material function. And this is so that we can have control over color correction and other options we might want to do. So again, right-clicking in our global functions, I'm going to go to material. I'm going to search for material function, and I'm going to name this one MF Albedo. So let's pop open MF Albedo. And the first thing I'm going to do is I'm going to search for my MF texture UV. We're going to use it in here. We're also going to do the same thing in our normal, where we'll use this in our normal as well. So first thing I'm going to do is make sure that we are getting a... Actually, the first thing I'm going to do is I'm going to delete this node. I'm going to go back into... No, I'm not. So the first thing I'm going to do is I'm going to make sure we have inputs that we can access, because this function doesn't know, this albedo function doesn't know, hey, we actually need to set these elsewhere. I can plug in a value here. I can plug in a texture, and it's going to use this. I can plug in a texture object, and it's going to use this without any problem. That is what we want to avoid. We want to make this something that's exposed outside of the albedo. So we're passing in things twice, I realize. Or passing in things through layers, I realize. We're passing in things through layers, I realize. So first we'll do our tiling, which I'm just going to promote, which I'm just going to pull off of and do function input. Hey, it gave us a vector 2. Nice. And this will be our tiling. Actually, I'm going to call this our UVs in this case, just so we know what it is. And the reason why I haven't set priority for our tiling to be below our texture here is I'm basing it on the order in which they go in the texture sample. So if I really wanted to, I could set that to priority 0 and this to priority 1, just to make sure. And remember, the lower the priority, the higher it shows. All right, so then we're going to do our texture. And again, I'll do a function input, and it gave us a texture 2D. And this will be our texture. And again, I'm going to set the priority to 1 based on what I just did. And just so we have a preview, we're going to do a texture object. I'll leave it as the default object for now, because why not? Now, why aren't we seeing anything here? Well, we're not pinned into the results, but we are a few steps away from that. And I'm going to need a little bit more room. After that, I'm going to desaturate our color here. And this is going to be where I put in my color correction. So holding down the 4 key, I'm going to get myself a vec4 node here. I'm going to convert to parameter, and I'm going to call this albedo controls. Now, under the default values at the bottom, I'm going to name my R channel saturation, my green channel brightness, and my blue channel contrast. And I can't remember what I actually named the do not use ones in our tiling. It was not used, wasn't it? Yeah, not used. So I'm just going to copy that to be lazy and put that into my alpha channel. Now, I'm pretty sure that Quixel does something similar. I'm not sure if they do it in a different order than me, or if it's the same order, or if I'm doing the same order as them, I guess. But this is a fairly standard approach. We are going to get the inverse of this value. So that is because we're doing desaturation instead of saturating. So we're going to do a 1 minus node, which gives us the inverse value. So that should be red versus black right now. And let's actually change this default value on these. They should all be 1. And as I change them, let me just refresh this node. We'll get black because we're going from 0 or 1 to 0. All right, and I'm going to plug that into there. Next, I'm going to do a multiply node. I'm going to multiply in our contrast. So I'm going to multiply in our brightness, not our contrast. I don't know why I said that. And I'm just going to pin that into there. And next, we're going to come back to contrast in a moment, actually. We're going to talk about color correction and a couple of options. So we can either blend colors in, or we can place a color or multiply our texture with a color. And this is an option, our first option we really have for some of our fanciness that we can do in color correction. So holding down the 4 key again, I'm going to create a new vec4. I'm going to rename this parameter our albedo tint. And in our albedo tint, I'm going to set all the properties to 1. And the reason for this is we are going to multiply this in potentially. And if I multiply 1 into anything, we get whatever we sent in from the other channel. Which means that if we have 1 in our red channel and we multiply it by 1, our red channel is still 1. Whereas if we have it defaulted to 0 and we multiply 1 by 0, we lose that red channel. So I like having the defaults to 1 just to make sure that whatever we're sending in, if we're not changing this node, is what we're getting out. So the first thing we're going to do before we actually plug anything into our multiply or albedo tint, as I move things over, is we're going to create a switch node. And this switch node will be a static parameter switch. And it will be use blend verse multiply tint. So on the true, we'll use blend. And on the false, we'll use multiply. So I'm going to create a multiply pin real quick. So I'm going to create a multiply pin real quick and plug into the B, our albedo tint, and plug into our A, our multiply from earlier. Put another reroute there. And I'm going to plug this into our false. So this will multiply into whatever our texture is, whatever colors we put here. For our overlay option, which is our blend option, not our overlay option, we will do blend overlay. And notice that we have it in miscellaneous and blends. It's the same. It's just in multiple categories. So if we pop that open just to show you what I mean. Oh, we actually can't see it in here. Never mind. But it would be like if I went here and added a second category. All right, into our blend vec3 down here, we'll put in our albedo tint. And it's going to plug everything back in that broke over here for some reason. Interesting. And then I'm going to plug this into our true. So now we're able to color correct our object. And then finally, I'm going to look for a power node. And I'm going to plug the base into our switch here. And then I'm going to come from our contrast, which is our exponent for our power. All right. So this will allow us to control our base color and our so this will allow us to control our base color. All right. Awesome. Let's go ahead and just apply and save that. Sorry if there's a wee bit of a jump there. My editor crashed. The joys of doing this with OBS open. All right, so before we leave this function, what we're going to do is categorize everything. It's going to be 0, 1, albedo. So it'll show up in the category for albedo. Let's do the same for our tint here. All right, everything looks good. And don't forget, we also need to do this for our switch node as well. And then finally, I'm going to rename our result as base color. All right, I'm going to save it real quick. And then let's go back to our object master. So in our object master, we're ready to set up our base color, which I'm actually, apparently this didn't save when it crashed. Cool. So let's redo our, so let's head back over to, object master. And in here, we're ready to set up our base color, but we're not going to do it over here. And that is because you might want to change things, like have rain effects applied to it. So I like to do things over here and then put my effects to the right of that. All right, so first what we're going to do is we're going to search for our MF albedo, which I have a lurking suspicion that I forgot to expose this to a library. Go ahead, save that. Now let's go back to our material or object master and do albedo. There's our MF albedo. Feel like that's backwards. Did I not forgot that I didn't save when I did this? Don't know why I just closed that. And we're going to refind our albedo. There we go. All right. Now for our tiling, our UVs here, we're just going to type in the word tiling. And again, that'll bring us to that node there. So that's where that information is coming from. That's the same as if I did this. But imagine we're doing that for every single one of our textures. It can get real messy. All right, and now for texture, I'm just gonna pull off of here. Actually, I'm gonna do a text object, and it's gonna be a texture object parameter, and I'm gonna name this my albedo texture. And this is gonna go into a different category than albedo. It's actually gonna go into a category called 00 texture. So all my textures will be at the top, and I'm just gonna give this a priority of 0. And I'm gonna set our default to black. And I'm gonna plug that into my texture there. And then down the road, I'm gonna have some noise that we might want to apply. You've seen that in some of my survival series stuff. But for now, I'm gonna do another named reroute. And we're gonna name this one our base albedo. Now, I'm not gonna be covering water effects in this, but if I did, I'd have my base albedo over here again. I would then do the water effects, and then I would have the final albedo, and then I plug final albedo into base color. But for now, I'm just going to base color do our base albedo. All right, and we have no errors so far. That's good to see. I'm not going to categorize this yet with or comment this out yet, but and that's just because I'm going to do the noise stuff as well. All right, next we're going to do metallic. And metallic's going to be a little bit different. First, what we're going to do is we're going to search for our MF texture UV. Again, I'm just going to copy the tiling node. I'm going to take tiling and plug it into there. So again, that would be like doing this. And that again can get real messy. I'm going to copy my albedo texture and rename this one to our metallic texture. Plug that into texture. And yeah, see, I guess you could plug the tiling into this bit. I like doing it through that stage. We're going to have, after that, our ORM check, but we're going to do that a little bit later. And then the next thing we're going to do is create another material function. And this is so that we can control our outputs, or so we can fine-tune how that texture is affecting our final texture. And that'll be our base PBR function. And so right-click in our global functions, go to materials, go to right-click in our global functions, go to material, go to material function, and this will be MF general PBR. So for any PBR texture I'm working with, this is an approach I use. So we have a few things we need to consider. One, are we actually using the texture? Because if we don't have a texture, none of this works. 2, what controls we want. And then 3, do we want to increase what we're getting from it or not? So let's handle the if we have a PBR one first. So what I like to do for PBR textures, I like to lerp. Now, I know in other software, when we're thinking about metallic is either 0 or 1. But all of these are really ranges of numbers. So for our PBR metallic specular roughness, it's a range of 0 to 1. So I like to be able to control that. And we have a lerp node here. And so what I'll do is take the texture as our alpha. And what I'll do is convert this over to a function input. And this has to be not of type scalar, but of texture. And I'm going to use the texture. Actually, sorry, I'm going to use scalar. It will just be plugging in the texture result. And this will be our attribute. So metallic, roughness, specular, texture. Then for our A, we'll do another function input, which will be of scalar type. And this will be called our min. And in the case of min, I do allow our preview to be our default value because it'll be 0 in this case. For our B, I'll do another function input called max, which I'll set as a default to 1. And since I'm only using a scalar parameter, it's going to be the first value here. We'll, again, allow that to be default, so we don't actually always have to enter it. And in terms of priority, I'm going to set our min to priority 2, our max to 3, and our texture to 1. What about 0? Well, that's actually going to be the check. Are we using a texture, or are we going to use a base value? And there'll be another priority 1 as well, by the way. We're then going to multiply this. Oops. We're then going to multiply this, and this will give us a little bit more fine control, and we're going to have an attribute strength. So we're going to do a function input, again, type scalar, that we'll call attribute strength. You can also call it attribute multiplier. I will default this to a value of 1. Again, I will set it to use the default. Why 1? Well, 1 actually doesn't change the value, so it's fine to use 1 and make it our default. Then I'll have a switch node, and we're using a, next I'll have a switch node, and we're using a non-static switch here, or non-static switch parameter. We're using a static switch because we don't want this to be something, because if we use this, oh God. Because if we use a static switch parameter, any function, any part of the material using this function will share this. I might have a metallic texture, but not a roughness texture, which would be weird. Usually I'd have a roughness, but not a metallic. So I want to be able to change this per texture type. And this is how I do that. I can use this node instead of a parameter switch and have a value for what we're putting in here, which will be a function input of type bool that will be called use texture attribute. I sometimes call this use advanced attribute. And for this one, we'll need to put a static bool in just for the preview to work. And we're going to leave this as false. We're not going to set this. This is something that you always have to set per material. You do have to control this. Whereas with these two, you can leave them as the defaults and it works fine. And then for the false, we'll do a function input. And this is if we do not have a texture that we can use as a lerp. What we'll do here is we'll set a value that we'll use as our default value. We'll use 0.5, by the way. We use 0.5 because the specular base value is 0.5. So, hey, we have, if we have a texture, we have if we don't have a texture. This parameter, by the way, this in that we haven't named yet, is our base value. It will be if priority type 5. Our attribute strength will be of priority type 4. And our use here will be of 0, so that's correct. And then finally, we want to clamp this. And we're going to clamp this by using a saturate node. Saturate is a cheap and effective way to get a value that's put in clamped to 0 to 1. All right, plug that into our output. And I'm just going to rename the output as attribute. And finally, expose to library. Okay, in our material then, what we're going to do is once we have done that, we are going to, or once we've done our UV, we have our ORM check as I mentioned, but we don't have that ready yet. So we'll do MF general PBR. And this actually goes into our attribute texture. And then we'll do a bool parameter, static bool parameter. This will be use metallic texture. And this will be in our group of O2 metallic. This will have a priority of 0 because we want it at the top of that group. And then we're going to create a bunch of scalar values. So metallic min, which we'll set to 0. It will be in our metallic group as well. We'll give it a priority of 2. Our metallic max, I'm just going to duplicate this to set that up more quickly. We'll just rename it to max. We'll give it a default value of 1. We'll set the slider ranges for both these to 0 to 1, by the way. And the priority for this value will be 3. That goes into our max. For our attribute strength, what we'll do is another scalar parameter called metallic strength. Again, we'll give it a default value of 1. This will go into our category of metallic. We'll give it a priority of 4. And the scale doesn't really matter. It does get clamped at the end. And then we'll do one more called metallic base value, which I've just seen a mistake in here. This base value should be a scalar. So let's go ahead and fix that. The only downside is this is now wrong. So we do metallic general PBR again. And we're just going to move the pins into the correct spots now. I do not know why this doesn't refresh correctly, but such is life. Go ahead and delete the old one. And this one will have, and this, our base value, will have a priority of 1, and it will be in our metallic group. So we set this at the top, and then it switches between everything else that we're doing with it. And this will be our named reroute base metallic. And we're going to go over to our metallic and do base metallic here. And we have an issue. Cannot cast from static bool to bool. Sorry, pop this open. We have one more issue. Under our input type, this should be static bool. Go ahead and apply and save. And now it should work. It just hasn't renamed here. It isn't so much of an issue. It will work, as you can see. Right. That takes us through metallic. As for specular, we're pretty much doing the same thing, except we're going to have a little bit of a change. So we don't always have a specular material, but we don't maybe like that plasticky look that Unreal gives us, that very classic Unreal PBR shader look. So what we're going to do is we're actually going to use the red channel of our diffuse as an alternative approach to a base value and to a texture. So first, what I'm going to do is I'm going to copy this albedo texture down here. And then I'm going to create a new material function based off one of the other functions we've already made. So let's pop over to our editor here and take our MF texture UV, and we're just going to rename, we're going to duplicate it and rename it MF spec as in specular, MF spec as in specular from BC base color. And we're going to just break the RGB and plug that into the red channel there. So we're going to get a texture object in, or yeah, texture object, and our tiling. All right, go ahead and save and apply this. We don't have to make sure it's already exposed to library, or don't have to expose it to library because it already is. And then what we're going to do is we're going to search for MF spec from BC. And then for our texture. But one thing I do want to change on this, just because how I organize things, is I do want to change our texture priority to 0 on this one, and our tiling to 1. This is just for cosmetic purposes. Now in our object master, I'm going to do MF spec from BC. Our albedo texture goes into our texture here. And then we'll do our tiling again. And this is why I wanted them reversed, because I want tiling on the bottom in this. Because we're also then going to duplicate our specular texture again, but this time we're going to rename it as our albedo texture. We're going to rename it as our specular texture. And we're going to do our MF texture UV. And that's the cosmetics I was talking about, just so I don't have crossing wires. We're then going to do a static switch parameter, which will be use albedo to get specular. So if we don't have a specular texture and we just want to use the albedo, well, that's our true. We're taking the albedo, we're getting the specular from our base color. And then if that's not true, well, we're going to get it from our specular texture. And then we're going to repeat what's up here. We're going to do our MF global, our MF general PBR. And again, that actually goes into our texture attribute. We can copy all the other nodes, bring them down here. I'm just going to give myself a bit of room to play with. Now, one thing we need to do and be mindful of is we need to rename these. So this will be use specular texture. It will go into the category of O3 specular instead of O2 metallic, and everything else remains the same. So O3 specular. When I say everything else, I mean the priority. Definitely need to change the names and groupings of this. Always change the name first, not the grouping. If you change the grouping first, it'll change it for the one that it was already sharing its name with. So specular min. And a really kind of nifty trick if you want to do this all in one giant go is copy these nodes. And let's go over to Notepad for a second and just paste them in. Go up to the top, do replace, and I'm going to type in the word metallic and do specular. Replace all. I think that should have been all of them. We're going to copy this, close it out again, paste it in. Specular max, O2 specular. Specular strength, O2 specular. Okay, I forgot to change the O2 part, so let's actually get these into the O3s. Whoops. So that should be O3. There we go. And that gives us all those nodes really quickly. I think I mentioned this in one tutorial video I did elsewhere where I was just generally doing something really quickly. And I was like, I'm just going to quickly name it this way. And this will be our named reroute base specular. Sorry, I was already looking for it even though it didn't exist. Just going to line those up a bit better. And then we can plug that into there. Base specular. All right. That one actually is done. So we can comment this one out as O3 specular. Next we have roughness, and roughness will be another weird one because we have three different ways of handling our roughness. So first, what I'm going to do just to make my life a little bit easier is I'm going to copy this entire section. And again, I'm going to repeat that notepad process I just did. I'm just going to paste it in here. And we're going to, this was metallic I copied, right? Yep. And we are going to then go to the very, very top of it. And we are going to do, when I say very top, I'm going to put the mouse cursor at the beginning, replace. And instead of doing metallic to specular, we're going to do metallic to roughness. Replace all. Then I'm going to search for O2 space dash. I'm going to do that to O4 space dash. And I'm going to replace all. Close that out. Come into here and paste it in. And look, we have roughness texture. We have use roughness texture. And then we have our texture group of O4 roughness. And then a new named reroute, except for it's the same color as the old one, of base roughness. Well, there are steps we have to do between here and there. And that's going to be our ORM and our ORDp stuff, but we can do our base roughness and paste it into there. If you do that copy and paste method, make sure to go through each of these and make sure they're in the right groups, they have the right names, there is nothing wonky going on. All right, if you have a missive, well, what we can do for a missive is we can, well, we're going to just, let's assume we have missive. This is a bit trickier. So for a missive, what we're going to do is first we're going to create a texture sample. We'll create it into a parameter. And we'll turn it into a parameter. We'll call this our emissive mask. So this is our mask for our emissive textures. It will go into the category of OO textures as well. And for this one, what we're going to do is we're going to take the albedo and amplify it so it's glowing. Let's say you have a stoplight that just flashes red and the metal frame around it. Well, the mask will mask out anything that isn't the red part, and then we'll take the red from the albedo and we'll amplify that or keep it as is, but we'll use that as where we're making it emissive. So we need a lerp to do this. We're going to create a lerp node by holding down the L key. This mask will be in our alpha. And because it's a mask, we really could do it on the R channel, and we should probably do that. But for now, we'll change this to, yeah, we'll leave it as that. We could make it a mask just to make life easier. And in fact, we will. We're just going to do this as black for now because we have nothing that we want to put in. For our alpha, we leave it as 0. But for everything else, for our B, this is where we're going to have our color. So we're going to multiply in our albedo. Now, before we actually put our albedo in, we're going to need to do our MF texture UV. What we could do, by the way, is come back up to here and get our base color. In fact, really, what we will do is just that. We'll take our base color. Or I think I called it base albedo, sorry. I take our base albedo. We're going to multiply our base albedo by a emissive strength. So we need a scalar parameter. We'll call this emissive strength. We'll default it to 1 so that we're not adding anything to it or taking anything away. This will be in our category of O5 emissive. We'll give it a priority of 1. Okay, now for our UVs down here, we're going to do our tiling. Sorry, I skipped that. All right, so this gives us our emissive color that we're using a mask to say, hey, don't make it all emissive. If you don't want to use a mask, you just make this into white. From there, we're going to ask, are we using a mask or not? So we're going to actually do static switch parameter, and it is use emissive mask. Now I'm going to put a reroute into this multiply from earlier. If we are not using a mask, sorry for the crossing pins, we'll come from that reroute into that false. And also let's just set this to our emissive category. It is element 0. And if we are using a mask, we'll come from our lerp into the true. And I'm just going to put another reroute in and organize this so it's a little bit easier to read. There we go. And then we have one more static switch we have to do. And this will be our priority 0 one. But first, let's rename it before we change our priority to use emissive. So one thing about Lumen, if you ever watch Matthew Wadstein's official Epic classes, if not, go watch them. Is he talks about something in Lumen, you know, if you have an issue where Lumen cards aren't being generated, apply emissive to it. Well, if you do that, and say you don't really want it to be emissive, sorry, if you do that, it gets a Lumen card. But let's say you don't want it to be emissive. Well, if you apply a value of 0 to it, it's still being counted in the emissive system for Lumen, but not actually emitting any light. So if we're using our emissive material, again, this is priority 0. Forgot to actually change that despite saying it. We're going to check if then we're using our emissive mask or not. If we're not using it, we're not going to set any value. We're not going to set a parameter. We're just going to set a hard value of 0 so that it'll still be caught in that Lumen thing that I mentioned earlier. And so we don't actually have to worry about it emitting light by mistake. And this will be a named reroute of base emissive. In fact, I actually don't tend to put any overlays on my emissives when I do this. So it doesn't need to be emissive. It can be final emissive. But just to be on the safe side, I always call it base. In case I change my mind in the future, then I don't get confused. All right, that one's actually done. So this is O5 emissive. Awesome. Next, we have our normals. All right, so normals are going to get a bit weird. We're going to have to create a new material function. So let's go back here. Let's create a new material function. This will be MF normal. Before I forget, let's expose that to the library. And let's change the output name to base normal. All right. So what we're going to do is first we're going to take in we're going to do our MF texture UV, like always. We're going to take in our function input for our UVs. Again, we do not want that previewing. We will leave that at priority 0. We are going to have a texture. And this will be our normal texture. So function input, normal texture. Again, we don't want anything in there. We'll give it a base value of 1. To make our lives easier, we are going, or sorry, a priority of 1. We'll do a material a texture object just as a example, and we're going to switch that from the default to the flat normal. Okay. Once we've done that, we're going to break the result so we can modify it. And the channels that really matter for modifying a normal are going to be our R and our G channels. We're going to leave our B channel as is. So what we're going to do is we're going to come from here. We're going to have a reroute in a second, but we're going to do a masked component or component mask. We only care about the R and the B channel, but we're going to duplicate that mask down here, and we're going to only care about the blue channel down here. Right, so we're going to do nothing to the blue channel. We're just going to leave this as is for now. We're just going to leave this as is. And then for our R and G channels of our normal, we're going to multiply, and we're going to multiply in a strength. Now, you could do it to the entire thing, but it's less important for the blue channel. Well, these channels matter more. So we're going to do a function input. It will be of type scalar. This name will be our normal strength. Our default value will be 1. It will automatically use that value if we don't put anything in, so we don't have to worry about it every time. Okay, so the next thing I want to do is consider if I want to flatten my normals or not. So flattening normals just means that if your normals have a lot of extra data that causes it to look weird. Like you might get that a lot with rocks, for example. It causes the actual object to look weird in the world. You can flatten it so that it doesn't have that issue. I am not, I'm not a huge fan of how Unreal does its flatten normal, so I like to make a little bit of a change from it. And to do this, what we're going to do is we are going to create our own flatten normal approach. So let's go back to our main window. So right click, let's go to materials, let's go to material function, and we're going to do mf flatten normal. Let's pop this open, and we're just going to expose this to our library real quick. And the first thing I'm going to do, we're going to do this a little bit backwards, just for the start, and then we'll go from left to right. I'm going to first do a switch node here. And that's the wrong sort of switch. I'm first going to do a switch parameter here, or a switch node, not a parameter. The first thing I'm going to do is I'm going to do a switch node, and I want a static switch. Don't want the parameter for the same reason as with the PBR stuff. And we are going to do a value here, which will be a static bool parameter called detail normal. Actually, you could use a static switch parameter here. You don't need to do it with a bool, but it's just the way I've always done it. Then I'm going to get my flatten normal from Epic, and I'm going to duplicate it. So what this allows me to do, actually I'm not going to duplicate because I like seeing the type of variable it is. What this allows me to do is either just use a normal flatten normal or to add more detail in, giving me a bit more control. So what we're going to do for this is we are going to create a scalar parameter. This will be called our normal flatness. And I'm going to set this to a category called 0, 7, normal. It'll be a priority of 2. And this is going to go both into our flatness, or into both of our flatnesses we've just created. Okay, there we go. And then we're going to take care of our normals. So for our normals, what we're first going to do is we're going to create 2 new inputs over to the left. And they are function inputs of type vec3, and one will be called normal or normals, and then we'll create another function input of type vector3 called detailed normals. So this allows us to take 2 different normals, a detailed version and a non-detailed version. We're kind of going to flatten one based on the other, or just use the other. So let's take our normals first. Let's just take this one. And we're going to do what we did earlier. We're going to mask out parts of it. So we're going to mask out our B channel, or only get our B channel. And then we're going to do the same with our RGB, or RG. Okay. With that done, plug that into there. We are going to take our B channel. In fact, I don't want this the other way around. Sorry. I don't know why I just switched them. We're going to actually do what we'll do in our normal in a second. We're going to merge these back together, but we're going to control the strength of this one in a different way. We're going to do a multiply node. That'll go into our RG mask. We'll do another scalar parameter called main normal boost. So this is the same as strengthening our PBR, strengthening our normals that we'll be doing, or that we did. And we'll give it a default value of 1. We'll give it a range of 0 to 1. This will go into a category of normals, priority 1. And then we are going to do an append. Sorry. We're going to do an append vector to re-merge these back together. There we go. And so now we have control over our main normal in terms of its strength. We're going to take this value and we're going to pass it into, if we're not using our detailed normal, so we're going to pass it into our normal here, our flattened normal. Okay. And then just to make life easier, we actually won't plug any visuals into it. For our detailed normals, we're going to do the same thing. We're going to take all of this, minus the append, really quickly, paste it down here, and we're going to split our detailed normals between the two of them. After our multiply, we're going to come off this multiply from here. Let's put a reroute in. And sorry, this one will have crossing wires. And we're going to do another multiply. And we're going to multiply in our detailed normals. From our detailed normals, what we're going to do is we're going to have a lerp. So we're going to take a lerp node there. This will become our A. Our B will be our non-detailed normals. And I'm going to move everything to the right so this is a little bit easier to see what's going on here. We'll take our non-detailed normals from this multiply and plug that into our B. And for our alpha here, we're going to create a scalar parameter called blend normals. We're going to default it out to be on the B only, and it's a range of 0 to 1. It will go into the category of 0, 7 normal, and it will also have a priority of 1. And that goes into our alpha. We then are going to take the result of this and we're going to multiply it again. And we're going to multiply it by, let me just move things over, is we are going to multiply it by a min-max boost. We're going to multiply it by a mixed normal boost scalar. So create a new scalar, mixed normal boost. And again, we'll give it a default value of 1. It will range between 0 and 1. Put it in the category normal. It will be priority 4. Plug that into there. Okay. We are then going to do another append node. And this multiply will go into our A. And then we're going to take our B from earlier that we haven't touched and bring that back into our normal. And this will give us a blend between our detailed normals and our base normal, thus giving us a bit more control over what our flattened normal's really doing, and if we want to get some details out of it and not lose it all. So back in our MF normal, what we will do after this append is type in MF flatten normal, and actually this goes into our normals 3 at the bottom here. Sorry, I skipped a step. We need the append node first. Let's do our append vector. Let's bring this texture back together. So we're bringing our normals back together so that we have our strengthened normal. Then this goes into our normals, this being the append. Okay. And then from this reroute, after our MF texture UV, we're going to pull off of here to get our detailed normal. So we're going to take our original normal. Now, yes, you could put a second normal in if you want, and you just have to redo all these steps up here and plug that into our detailed normal. But I'm just going to assume we want to take our original normal twice, get some detail from it, and remove the rest of the detail. Okay, the next thing we're going to do, the final thing for this one really, is do a switch static switch. This will be on our true. For our false, we're going to actually come from our normals here and go into the false. So what we're going to do is we're going to check, hey, do we want to flatten our normals or use our current normals as is? If we're using our current normals as is, well then that's our false and we're just not going to use this node. So we're going to create a function input. It will be of type static bool. I'm not going to make that mistake again. Called flatten normals. We'll give it a default value that we'll accept. And to get that default value to work, we will do a static bool. Guess it'd be helpful if I had both the t's and the word static, which we'll set to false, because we're going to assume by default we don't want to flatten our normals. We're going to plug that into base normal, and hey, we're good to go. Let's go back to our object master, and in our object master, we're going to do a new texture. Let's just grab our roughness texture here. And we're going to rename this as our normal texture. Leave it in the same group as before. Then we're going to search for mf normal. And before we leave here, let's just very quickly go through this and make sure our priorities are correct for everything. So for our normals, we want priority 0. For our tiling, let's make sure, before we leave here, let's make sure our priorities in the correct order. For our UV, we want it as 0. For our tiling, we want it as 1. For our normal strength, what we'll do for that is put it at category priority 5. For our flattened normals, we'll use also category 5. Oh, sorry, 6, not 5. All right, let's go ahead and apply and save. Let's head over to our object master, and let's just copy our roughness texture. Let's rename it as our normal texture. Leave it in the category normals. And then we're going to do our mf flatten normal. Sorry, we're going to do our mf normal. We're going to plug in our normal texture to our normal texture. We're going to get tiling. We're going to plug that into our UV. And then for our normal strength, we'll create a static parameter, or we'll create a parameter, scalar parameter called normal strength, which we'll set to 1. We'll plug that into our normal. And then for our flattened normal, we'll create a static bool parameter, which will be called flatten normals. We'll set it to default. We'll set the default to false, I mean. And then let's just quickly categorize everything in here. So our normal strength will be of 07 normal. I'm just going to double check I did normal and not normals. It's in our flattened normals, I did them. It is normal. Okay, cool. And then same for here, it'll be normal. Our priority for our normal strength will be 0. Our priority for our flattened normal will be 1. And that is our normals done, actually. So we can do a named reroute. This will be our base normal. And we can just put this in a category called 07 normal. And I'm annoyed that I just rotated that by accident. And let's go up here, find our normal, and do normal. And look for the named reroute version, which should be at the top. Or base normal, I guess. If you're wondering where the numbers are coming from, count the output, or count the inputs for the final node here. 1, 2, 3, 4, 5, 6. It's the 7th one we use. I guess opacity really should be 7. Opacity mask should be 8. This should be 9. Yeah, that might be something you want to change. Next, we're going to do ambient occlusion. And ambient occlusion is the final base one we have. And then we're going to very quickly make a material instance and test out the textures. Make sure they're working correctly. Make sure the material's working correctly with the textures. So let's grab our normal texture. Let's duplicate it. We're going to rename this one our ambient occlusion texture, which I'm pretty sure I just spelled wrong. So you know what? I'm going to cheat and come over here for a second. I did spell it wrong. Cool. So ambient occlusion. No, I did spell it wrong. I'm having a moment where I'm misreading things. Cool. So let's bring this back down to the correct spot here. And for this, we're going to do our MF texture. Sorry if the sound got weird. My mic moved and I didn't realize it was moving. Plug that into texture. Get our tiling. Plug that into our tiling there. And then we're going to have all our ORM and ORDp stuff going on. But outside of that, well, we're going to take all of this. We're going to paste it down here. And that will go into our ambient occlusion. We're just going to change the names on this from use roughness texture. And to make sure I don't spell things wrong, I'm actually going to copy the word ambient occlusion or words and change roughness in each of these to ambient occlusion. Change the category of this to 09 ambient occlusion. And then repeat that for everything else on here. I won't change the scales. I won't change the priorities. I'm just going to change the name and the category. Oh, always change the name first, not the category. As I was about to do, that would have meant the roughness one would have shown up in the ambient occlusion because, yeah. Right, and then this is our named reroute base AO. Mostly I don't want to talk about ambient occlusion again, even though I have it in the paste buffer. And we're going to do base AO here. All right, that gets us through setting this up to test it. So let's go ahead and test it before we go into handling our ORM, ORDp, and noise options. So let's go back up to our materials. Let's create a new folder called instances. Like I said, we're going to have 3. And let's go back to master opaque, create a material instance called MF metal plate non-CP, just so I know it's non-channel packed. Put that into our instances. I did not mean to copy it, I meant to move it. So we'll delete this one. Okay. So we have our textures here. Now, you might want to set some of your defaults automatically. Let's go back and actually quickly handle that. We are always going to use a roughness texture. So we can mark that as true. All right, that's the only one I really wanted to switch. So now in here, I'm going to go get our albedo, our normal, and our roughness. And I'm going to pop back over to our textures here. Let's get our diffuse. So that's our albedo. Let's get our normal. Plug that in. And now you can see, hey, we have our normals. One thing you might want to do, and actually we're going to make that change real quick, is we might want to inverse our normals if you have a normal that is backwards for some reason. And then let's get our roughness. Okay, so that's our base setup. Before we continue, I am going to make that change that I mentioned. So in here, under normal, I want to make one small change. And that is, I'm going to just branch in here. I'm going to put a static switch parameter. And this will be B inverse normal. If false, we go into there. If true, what we're going to do is we're going to do a 1 minus node and plug that into the true. And then we're going to plug that into our base normal. By default, I'm going to assume our normals are set up a way that Unreal likes it. Okay, so let's just save that real quick. Let's go back into here, and let's just see what that did, just so you can get an idea of what I mean. Let's also then make sure that we've categorized that setting into normal, and I'm just going to give it a priority of 10. I can't remember the highest one I have. I think it's 6, but I'm going to have that at the very end. Actually, I'm going to give it a category of a priority of 0, so it's at the top. Okay, so if we go to normal, and I put the B in because I'm so used to bools. Let's get rid of that B. We don't need it. All right. Let's just inverse that and see what happens. And let's actually put it on a plane so it's a bit easier to see. So if we inverse it, Notice that those are more embedded now. I mean, it's kind of hard to see like how the light's bouncing off of it, but it gives you an idea. Actually, I think this should be inverse. That looks slightly better to me. Right, so let's take care of the other stuff. We'll ignore the globals for a second. We have our textures. We're ignore albedo. Let's give it our metallic texture. So, hey, now it's looking for a metallic texture to use. So let's go into here and let's do T, metal, plate, and I'm just going to copy that, and we're going to look for the M. All right, we're not seeing much of a change. That's fine. You know, it's a fairly standard thing. Let's do our specular. And I've noticed a mistake. We don't see our use specular from albedo. So let's go back into here, and we need to change this to be in our group for specular. This is why that organization matters. And we're going to give this a priority of 1. Apply and save. And then let's give our specular texture. And we want the one labeled S. And let's quickly just turn this off. So notice now we don't have access to our albedo because our albedo is an actual texture, but we can override that texture by doing that. And we can get our albedo from, or our specular from our albedo. Let's turn it off for now though. Okay, so that's our specular texture in. What other textures did we have left over? We already have a use roughness texture, so we're always going to do it. We don't have any emissive, so that's fine. Just want to make sure I haven't missed any. Yeah, we've missed ambient occlusion, so let's add that in. Don't think we'll see much of an effect with the ambient occlusion, honestly. But it is just good to have that in. And then we want the first one. Cool. Cool, so we have them all in. And let's just take a quick look at our albedo tint for a moment here. Let's just change our tint to make it more bluish. So that is if we are multiplying it in. Let's do it as a overlay, so we're blending it. And let's see the effect it has. So you can see that the blue, it's kind of hard to see, but look at this section as compared to that section as I turn that on and off. You can see that it lightens it up, it applies it more directly into it, whereas this seems to be like a paint layer on top of it, and it has that sort of nice chipping effect there. Let's just turn that off for a second. And then let's look at our albedo controls. Let's look at what saturate does. So we're going to go more negative, hotter. So that is our saturate. Let's just reset that to 1. Our brightness. And then our contrast. So that's the effect of our albedo controls. For our rotation, let's just rotate the angle it's at. So if you set it to 0.15, for example, we're going to be at a perpendicular angle to where we started. Let's set it to 0.5. We'll be at a 90-degree angle, and then 1 should be a 180. Okay. Let's set our rotation center. Let's set it to 0.25 in both axes. You won't see a change until we do the rotation angle. And notice now it's rotating, instead of from the center, around this corner. All right, let's set that back to 0, 0.5, 0.5. So that 0.5, if you imagine it's 0 to 1, 0 to 1. 0.5 is halfway up, halfway across. All right, let's change our tiling to see what happens here. So as we increase it, we get more tiling. As we decrease it, we're zooming in. And then we're getting the inverse of the image. So that back to 1. For our UV offset, let's just set that off so we can stretch in the UV. We can stretch in the Y. Again, set that back to 1 and 1. And then for our scale, well, let's change our scale. We can stretch it in either direction. We can also shrink it in either direction, I guess. I shouldn't say guess, I know we can, but easiest way to explain it was shrinking. All right, so that's our global, that's our textures. We've looked at our albedo tint, which I actually am going to revert back to 1 and 1, just so I have it at the default settings, even though they're not active. For our metallic, let's change our min to be 0.75. And notice now that we have a lot more metalness showing through, so that our minimum metalness is always 75%. Let's decrease this to 0.25 and decrease our max to 0.5. Now we have less metal showing through. So that's that control I was talking about. Also, let's actually put this at 0.75 again for a moment. Let's increase our metallic strength. And notice as we increase the strength, it does saturate a bit. We are getting clamped by that saturate, but again, we have more metalness showing through. Let's set that back to 1. Let's set this back to 0. You don't need to reset them. If you unclick them, it will go back to the defaults. We've already looked at the specular in terms of that. Let's change our min, though, to make it more specular. So we have that more plasticky look going on. But let's say we don't like that being so specular. We might want to set the max to 0.5, which is the engine default, by the way. And then you can do the same for the roughness. We can make the roughness much more noticeable. We can decrease how noticeable the roughness is. So this is that control I was talking about earlier. And same for the strength, same idea here. For emissive, let's actually just make it glow. Hey, it's already glowing. Cool. It really shouldn't already be glowing, but let's make this less emissive. So that's the base value. That's when we're making it emissive. And let's make it really glow. That's a very hot piece of metal. All right, so that's our emissive. We don't have any masks I can work with to make this visible. Actually, really quickly, let's just make this glow again. And then let's say we are using a mask. Well, now, because we have a black mask, black is blocking it. White is going to be where it shows through. Let's switch this over to white. And then if I put in a white square texture, it's going to be emissive in that white square texture. I saw a texture earlier I want to try just to demonstrate something. And I don't remember the name. I should have really looked at it. Well, hey, let's use the color checker. Notice that where the white is, it's more emissive. All right, let's get rid of that mask. Actually, set this back to the default value of black. And set the emissive strength back to 1. And make sure that it's not emitting. And then for our normal strength, let's increase that. So you can see what happens as we increase that normal strength. And in fact, actually, I kind of like the increased normal strength on this. Kind of brings out some of the more detail. Let's inverse the normal again, or uninverse it and see what happens. Yeah, this actually should be inversed. This is embedded the wrong way. So we do want to definitely inverse those normals. This, I think, is the texture is meant for OpenGL, which has a different normal. Really quickly, let me bring that up on screen. So really quickly, this image comes from the Stack Exchange for Blender. So OpenGL is on the left here, and DirectX is on the right. Notice that this is raised here and indented. This is how I visually see it, or raised with embossed letters, whereas indented with raised letters. So what's happening is the normal we have in the texture is an OpenGL texture. We're working in DirectX, at least I am, so we need to inverse that normal. So that's all we're doing with that inverse normal. And then we can flatten the normals. And, you know, honestly, let's just change the normal flatness. So you can see there we go. We're getting some change to the texture there. Change that bit. So there are the effects we're able to achieve with our base setup. Right, I probably am going to split this video into multiple parts because it is already extremely long. I apologize for that. Actually, I want that back at 3. Same idea with the ambient occlusion. We're not going to see much. You'll see a lot of stuff with that if you're looking at transparencies. But for now, we have our base setup. As I said, I probably am splitting this into multiple videos. But for now, I'm going to keep going and work through what we're doing. I'm just going to take our instances here and apply it to our objects in the world, just so we can see what it looks like. And in fact, I'm going to apply it to all 3 parts of this one. There we go. So we can just see how it stretches, how it wraps around things, what it's doing, where we might want to edit things. Right, so next, because we have ones already set up, we are able to use it. But what happens if you have channel packed objects? what happens if you had different materials or textures using different channel packing procedures? Do you have to create a new master? Well, yes, you could do that, but that's not efficient, and we're violating dry. Whereas we can just modify this to handle different texture types. So what we're going to do for that one is we're going to create 2 new material functions to handle parsing our ORM and ORDp materials. So first we're going to open up a new global function, a new material function. So right click in your global functions folder, go to materials, material function, and I'm going to do mf ORDp. And this is going to have 3 output pins, but we need to make sure we name them. The first will be occlusion ORDp, and that's going to be priority 0. You're going to have another result pin, sorry, output pin, not tangent output. We're going to have another output pin. So function output, this will be our roughness ORDp. This will have a priority of 1. And I'm just going to line those up with Shift A. And then another function output of our height or displacement ORDp, priority of 3. So we are getting 3 things from our inputs, or from our single input, which will be the split between our channels. Now, why are we splitting them this way? Well, then we can control various aspects of them. So let's do a function input, and this will be a vec3, and we're going to call this our ORDp texture. And then we are going to mask. We're going to have 3 things coming off this. We're going to have 3 component masks. So not make, mask. And I'm just going to copy this 3 times, and we're going to go into each of these, and we're going to mask out different things. So for our top one, if we think about the order I have them here, we're going to mask these out in that order. So we want the red channel first, we want the green channel second, and we want the blue channel third. I'm going to line it up to the middle one. We are going to multiply each of these. Now, sometimes in some projects I will switch out the roughness to do addition instead, but or I'll even lerp in some cases. I just kind of prefer multiplying nowadays. I don't know why. It just feels easier and neater. I'm just going to line that multiply up with that output. Line them up. And I'm actually going to raise these up because I do need a bit of room. And I'm going to raise these down. Plug that into there. Line them up again with the Q key. Plug the multiply into our output roughness. Line up with the Q key. Okay. Let's move these to the right a bit. And then each of these are going to get a function input. So I'm going to do a function input. It's going to be a scalar parameter. And really quickly, I want to check something on my normals because there can be a problem with the normals if I didn't get this right. It is a vec2. If you're getting weirdness where they're getting like lines through it, this is probably a scalar by accident. I've made that mistake a couple of times. So this is scalar. This is going to be our occlusion blend ORDp. Plug that into there. We are going to give it a default value of 1 that we'll use as our default just in case we don't put anything in. We're going to do another function input that is type scalar. This will be our roughness tint ORDp. Again, we'll give it a value of 1 by default because we're multiplying in. We want to give it some default value. And then we'll do another function input of our height strength. And again, we'll give it a value of 1. We'll use the default value. And let's categorize things. So our input pin here will be our first. Then we will have this as our second, or 1, 2. Sorry about that. I'm clicking things by accident. 2, and then 3. All right, let's go ahead and save this. And then let's do our ORM one. For our ORM one, what we're going to do is we're just going to browse to this one. We're going to duplicate this, and we're going to name it MF ORM. Or ARM if you prefer ambient instead of occlusion as your keyword. Now, we're going to leave this one pretty much as is, except we're going to rename it to metallic. In fact, actually, let's do our outputs first. Our occlusion stays the same, except for it's now ORM. Roughness remains the same, except for it's now ORM. And height gets renamed to our metallic ORM. Right. Let's get rid of the multiply. We're going to rename this also ORM. And what we're going to do is we are going to lerp between the value that we are bringing in and a value of 1, with our occlusion blend being an actual blend. That's why I named it blend originally, because this was a lerp in my old form of doing this. Plug that into the occlusion output there. And I'm just going to bring those back up a little bit. For our... I just saw the typo there. Sorry, I'm going to fix the typo in the original one. Roughness. Tint ORDp. P should be lowercase. For our roughness, this will be our, again, roughness tint ORM. We are going to add it in. Again, you can use the same approach for the ORDp. I just found that this works better for ORM and ORDp works better with multiply. This remains the same, and we're going to rename this as our ORM texture. Okay, awesome. Go ahead and save that. And we are ready to return to our material or our object master. And I'm going to move all the nodes outside of the tiling down. Not to the left, I'm going to move them down. Okay. So what I'm going to do is I am going to first take this albedo texture, duplicate it, and I'm going to name this my channel packed texture. If you want to go through and give the texture types different priorities, go for it. I don't for some reason. We are then going to do our MF texture UV. That goes into texture. Tiling, of course, goes into here. Okay. Then what we're going to do is we're going to go back to our ORM. Make sure it's exposed to library. Save it. And same for the ORDp. I know I said those in reverse order. I did the ORDp first, and now I'm doing the ORM. I'm going to just save all real quick as well. And then I'm going to search for MF ORDp. At least I caught it before I tried to search for it. And MF ORM. Awesome. So what we're going to do here is we're going to take this value and we're going to pass it into both of our ORM and ORDp. Again, I know I'm saying that in backwards order. Right, we're going to take care of the outputs first. So we're going to do a named reroute of ORDp occlusion, a named reroute of ORDp roughness, and then we don't actually use height in this. The only reason I have a height one is because a lot of channel pack stuff from Quixel is height based. So then we'll do a named reroute from our ORM version of ORM AO. Actually, I'll do ORM occlusion. I'm not sure why I was going to do AO. I've done a occlusion up here. And then we'll do another named reroute. This will be our ORM roughness. And I'm putting ORM or ORDp at the start because of when I call them, I want to know which one I'm actually calling. And they'll do another named reroute for our metallic of ORM metallic. Now, one thing to note is you might say you're using channel packed. The way we're going to approach this won't know, hey, we're using the metallic one, for example. It will know the roughness because we have said, hey, roughness is always true here, unless we've changed that. If you want to make sure that the roughness is being included, or sorry, the metallic is being included. If I can find metallic, it's somewhere. It's up here. So we want to make sure the metallic is being included. In the instance, we have to mark this as true, even if we're saying we're using ORM. And that's because it reads the nodes this way. So it looks at this and goes, right, am I using this texture? If not, well then it's like having that unpinned. It goes, nope, it doesn't exist. If I am, then it reads this. So if we're saying we're going to plug in our textures here for ORM, and if it's not saying it's using a texture, well, it's not going to look this far. So it's not going to pull this metallic ORM or ORM metallic. Okay, so that gets us through the output. So I still want to have control over these. So I'm going to create a new scalar parameter called occlusion blend. I am going to default it to a value of 1. I'm going to put it in the category of 09 ambient occlusion, and this will go into both my occlusion blends here. Okay, we have some crossing pins here, I realize, sorry. We're going to cross as little as possible. I'm going to create another scalar parameter of roughness tint, which I'll give again a value of 1. And these will only show up, by the way, if we are working with ORM or ORDp. They won't show up in the instance for the same reason as I mentioned a moment ago, unless we have these active. And this will be a category of roughness, priority of 1, and the occlusion blend will also get a priority of 1. For our height, we're going to do nothing because, hey, we don't actually use it. And then we'll do a metallic strength adjustment. We'll give it a default value of 1. We'll put it into a category of metallic. And it'll also have a priority of 1. And that goes into metallic strength. That is literally all we have to do to unpack our channels and have control over them. So I'm just going to name this ORM, or channel packed information ORM ORDp. All right, so that's done. Cool. And I just want to see where I had things lined up. I'm going to line it up there. For our albedo, we're still not done. We have our noise to add in, which we'll do last. But let's go to our metallic and finish our metallic out. So what we're going to do for our metallic is pretty simple. We're just going to push this forward. And then we're going to do another static switch parameter. And this will be called use ORM. And we'll put this in a category of globals, which we don't have the global one in here. So we'll create global. And again, it's global because it's affecting everything. So if this is false, we're going to go directly into there. I'm going to just break everything for a second. If it's false, we're going to take directly from this texture UV, plug into the attribute texture there. And I'm going to just line everything up again. If it's true, what we're going to do is get our ORM metallic. There we go. And then we can bring this closer again. So again, remember, if we don't say this is true, it's like not having that pin. It's not going to, even if this is marked as true, it's not going to go, oh, I need to use the ORM. If we're using ORM, you need to mark the use metallic as true. All right, so this is O2 metallic. Right, our specular is done, so we can just bring that up here a bit so we have a little bit less like white noise, so to speak. Our roughness is a bit more complex. It's the most complex out of all of them. And same with the, actually, ambient occlusion has the same issue, really. So we're going to have to do two things here. First, we're going to copy this use ORM. We're going to paste it in here. We're going to plug that into there. And then, and mindful of the ordering of this, let's on the true do ORM roughness. Okay, we got the roughness from there. Well, once if we aren't using ORM, well, we're going to check, are we using ORDp? Which means that, sorry, we don't have that node yet. Use OR static switch parameter. Use ORDp, which I have got wrong. Which would be lowercase p. If we're saying this is true and this is true, if we say both using ORM and ORDp is true, it's going to default to using ORM. That's because the order we pinned these in. It's going to stop here and go, this is true. Oh, yep, I'm using this. So if both these are true, Notice how that error isn't there, but if I turn this to false, we get an error suddenly. If I turn this back to true, that error goes away. That's because that true overrides whatever is passing through after from the left. So just be mindful that if you want to use ORDp, ORM has to be marked to false. So if we are false on using ORDp, cool, we're good to go. And if we are using ORDp, we're going to do ORDp roughness. And that is our roughness. Okay. Our emissive is already done. Our normals are already done. Our occlusion. Well, honestly, what we can do is just copy these two nodes, come back down here, and paste them in. I don't know what the heck I just copied. I do know what I copied. I don't know how I copied it. I thought I had those nodes selected. There we go. Let's give myself a bit of room to play with. And let's take these two nodes. False goes into the use ORDp. That goes into the use ORM. And then we just need the ORM occlusion. And the ORDp occlusion. Okay, cool. Let's just put this into a category of, I forgot the number, I think it's 9. Should really know this by now. Guess it'd be helpful if I actually select one of the nodes that's right. Yeah, it is 9. I often doubt myself on what numbers I've used. Okay, so now we're ready to test our channel packing out. Cool. What we're gonna do for that is we're gonna go back to our materials. Sorry, our instances. We're gonna duplicate this and we're gonna do ORM. And really quickly, we're gonna select both of these. It's part of the reason why the color correction's there, so we can look at it left and right. And we're gonna apply to this, the ORM one. We'll see no difference right now because, hey, it's literally the same thing. And in fact, what I'm gonna do is I'm gonna take this thing one more time, move it here, change one of them to the ORM one and one to the non-channel packed one. And then I'm gonna make a third one really quickly, just so I have it ready, ORDp. Sorry, I am experiencing a lot of lag, which is why I'm misclicking a lot. And it is pretty bad on rename right now. There we go, got it finally renamed correctly and drop it there. So we can see all three on one object. But for now, let's focus on this ORM one. So let's open it up. I meant to double click it, not click that. And under globals, did I not categorize them? Did I totally actually forget to categorize them? I did. These should be in global. We're gonna apply and save. Let's go back to our ORM version. And in globals, since we are doing ORM first, we're gonna mark this as true. And notice now we're looking for the channel pack texture instead. And we are going to use our metal plate ORM. Let's save. And let's also save all of this really quickly. And let's see if we notice there's any differences between these two. All right, so to me, just visually looking at this, this is a bit brighter. So I'm just gonna take this ORM out for a second. And I'm gonna just look at our settings. This might be related to needing to fine tune some of our settings. So I'm gonna mess with our strength adjustment and go up a bit. Let's go to 2. That is too dark. Let's split the difference and go to 1.5. To me, that 1.5 looks a little bit closer. And also, it could be our roughness that's causing issues. So we're going to change our roughness tint down. Nope, up. And actually, I'm going to undo the metallic strength while I do this. Okay, I definitely want the metallic strength up. Let's go to, let's just put an absurd number in, which won't do anything. Okay, so that seems to make it a bit better. Also, I can, of course, control saturation to see if that will help, or the brightness, or other aspects of it to get them to match a little bit more perfectly. There we go. I want to lower that brightness just a bit. Let's go to 0.75, 0.65. Split the difference, go to 0.7. And then contrast, let's go down a bit. Let's go up to 1.1. Let's go to 1.05. There we go. That is a lot closer. Now, it is still slightly off, but it gives you an idea of what we can do to control for things. And then on this, let me just save this real quick. Pin that into there. Which one is our ORM? I'm just going to default this out to the default one so I know which one it should be. All right, it's that center bit. And honestly, looking at them, I can't really visually tell that these are different textures or materials using different textures. And then for our ORDp ones, let's just duplicate these again. If you don't know how I'm duplicating, I'm holding down the Alt key. And we're going to put the ORDp ones on all parts of this stuff. So that's ORDp now. That's all ORDp. Let's pop this open. And here, we're going to switch to using ORDp instead. I just want to make sure I did use the right one in here, because I am paranoid. I did. And for ORDp, you notice, by the way, when we turn on use ORM, the ORDp option vanishes all in. So you can't really make that mistake about turning both on at the same time. So this is ORDp. There's our channel pack for ORDp. Let's go ahead and save this and pop over and take a look. Again, it's a bit lighter, which is telling me there's something in my roughness channel. So I'm just going to unpin that from up there. And I'm going to move this over. And this goes down to our roughness. And I'm just going to change our roughness tint. Darken it a bit. And we're going to just set that to 2. Same for our roughness strength. We're just going to increase it to 2 as well. For our ambient occlusion, really shouldn't be playing a role. We aren't using anything else. And then we're going to do our contrast. Darken it a bit. Set it to 1.1. 1.2. Okay. Go ahead and save that. Okay, and let's take a look at this version. Again, while I can see them being different, looking at them separately, it is much easier to actually see it the same here. Now, I will say most textures I have worked with, when I do switch them between the 3 forms, because that's how I test it, I can't notice a difference. Now, I'm not sure why I'm noticing a difference here. This is actually kind of shocking to me to see. All right. So the next thing I'm going to do is close out all of these, which even though they have been saved, I don't know why it's giving me such a hard time about that. Yes, save it. We are going to then handle our noise. Now, in some cases, you might want to apply noise to everything. Like it might mess with the normals. It might mess with the roughness. I don't for our base opaque objects. I will do that for things like our clear coat objects. So that's that last bit there. And for noise, because it is technically something I'm overlaying, what I like to do is move this to the side. And if you see my survival series, you know exactly what I'm going to do. This is actually standard. Epic uses this. So what we're about to do isn't all that huge. I have a little bit of a difference I'd like to do, which is I like to mess with the UVs a tiny bit. So let's go back to our global functions. Just save all again. We're going to create a new material function. And this will be mf_randomizer, because it can be used for randomization and noise. So we're going to do the same thing multiple times and then group them together. So first thing we're going to do is we're going to get a texture coordinate. From this texture coordinate, we're going to do a multiply node. From the multiply node on B, we're going to have an input value. It will be of type vector2. We'll rename it all in a second, by the way, because we're going to copy all of this, and there's some weirdness when we do that. We're going to have another multiply node. We're going to leave the value here for 1 for a moment, because we'll come back to that in a second. And then we're going to have a texture. which we will convert to a parameter, which will be our noise texture. On this texture, I am going to do a shared wrap. Oop, wrong one. Texture group shared wrap. I am going to put this into a category, however, called 11 noise. Priority doesn't really matter to me. This multiply goes into our UV. For our noise, we're going to search for macro variation. If you can't see this, click this cog, show engine content. It is default in the engine. We are then going to do off the RGB, an add node. And then we're going to do another function input node. And this will be of type scalar. All right, so what we're going to do is just move this all to the right. We're going to copy this once, line those back up, and then twice. All right, so let's go through them top to bottom. On our first texture input, we aren't changing anything. For our input event down here, we'll call this UV variation 1. We'll put this in a category of priority of 0. We'll give, actually we're going to change the priority. So we'll do, we're going to do priority of 0 on this as well. Sorry, I'm just thinking about things. For our add, we're going to do variant contrast 1. Priority of 1. For our text coordinate 2, we are going to change nothing on this one. You can, if you want, by taking the values we're plugging into here. Sorry, I forgot to put our default value in. Our default value for the first variant, UV variant, is 0.2 by 0.2. Instead of having this multiply, you could just change the values here to 0.2 by 0.2, but then you lose some control. And I'm all about having control over these things. The next one would be UV variant 2, and this will be 0.05 by 0.05. Our priority on this will be 0, 1, 2. This will be our variant contrast 2. Its priority will be 3. Then for our third UV, we aren't going to change anything on that, but for our input, this will be our text coordinate. Our third UV will be UV variant 3. Our values will be 0.003 by 0.003. Also, I forgot to mark these should be accepted by default, so we don't have to change it. Same for our inputs. Let's just quickly do that. Right. And that's 3. The set priority for this will be 4. Our last function input here that we have will be... Sorry, all the numbers are off. This should be 1, because there is going to be a 0 elsewhere. 2, 3, 4, 5, and the last one will be 6. Okay, and that will be our variant contrast 3, which I think I forgot to set our default values for any of them. So this variant contrast will be 0.5 by 0.5. Sorry, it's a scalar. 0.5, nothing else. Our second one will also be 0.5. And our third will also be 0.5. Okay. Then we're going to take the second one and we're going to add it. Sorry, not add it. We're going to multiply it to the third one. We're going to take the resultant of that multiplication and multiply it into the first one. All right, now theory, you can delete this multiply we have and we're good to go just by plugging that into there. And we will plug it in just so we can see what's happening. There we go. Also, I want to have everything kind of lined up. So we're going to take the texture coordinates, line them up, take these pins, wrong key, Shift A, not Control A. Same for the variance, line them up. Same for the multiplies, same for this bit. Actually, we can do that. And I'm happy with that. We're good to go. But I like having one more option. And again, we're going to have a little bit of crossing pins. And that's going to be a static switch parameter called use absolute position. For now, what I'm going to do is a scalar value of 1 on the false. And then on the true, I'm going to do a function input of UVs, called UVs, that is. It is a vector 2, because it's a UV. And yeah, the default will be false. That will go into the multiply. That will go into the multiply. You could just use a named reroute here, I guess, instead, but not so much of a big deal. However, it probably would look nicer and neater like this. Okay, I'm just going to double check that everything seems to be set correctly. So these should be scalar. These should be vec2s. That should be a vec2. Yep. Okay, let's go ahead and apply, save, close that out. I think I skipped one small step. Let's open it back up. Expose to library. Save, apply, close it out. Now, in here, what we're going to do is we're going to search for our MF randomizer. Okay. We can leave it as is, except for the UV part there. We're going to pass in our tiling. And then we're going to have a return called, or a named reroute called noise. Really, that's all you need to get to have this thing work. And let's plug it in and just see what it's doing really quickly before we add in other stuff. And then we're going to have a switch parameter called use noise. If this is false, we're going to come directly into there and plug into our base albedo. If it is true, however, we're going to multiply. And we're going to multiply, and I want to move this over a bit, our base color from our MF albedo here into our A. It doesn't really matter, it's multiplication. I just like having it in A. And into B, we'll do our noise. Sorry, I'm going to type in noise again and then scroll to the top and pick the correct one. Your named reroutes are always at the top. And this is 01 albedo done. Okay. So, I'm actually not sure we'll be able to see. Actually, we might be able to see this. So let's turn this to true for a second. Now it's too dark. Let's just really quickly use our metal plate diffuse. And look right there at that splotch. Watch it go bye-bye. So that's what's happening when we have that on. Now I'm going to set this back to... Actually, we'll use the default texture because, yeah, you can see stuff. There are the splotches with the default texture. There they are gone. So if we want control over that, all we have to do is create a bunch of parameters. So I'm just going to pull off of these or right-click and do promote to parameter. UV variation 1. I will default the values to 0.5 by 0.5. We don't need to actually see the color. Contrast. Promote to parameter. Again, I'm just going to delete the type of variable it is. And I'm going to set that to 0.5. And we're just going to repeat that down the line. Promote to parameter, delete the last little bit. Our default for that is going to be 0.2 by 0.2. Again, we don't need to see the color. Promote to parameter. Again, 0.5. As you can tell, I'm using the default values anyway. Same for our UV variant 3. But this lets us stretch or change the noise we're applying. It gives us a bit of fine-tune control over it. Oop. And this is 0.03 by 0.03. I do like using squares for this one, for this particular noise texture, because otherwise it looks stretched and weird. And then we'll promote this to a parameter, and this will be our... I think I spelled something wrong on that one. I got the name wrong compared to the others. Oh, also, I should rename this really quickly to 3, set it to 0.5, and I'm going to go back into this function, and I named it const variant contrast 3. Can't believe I did that. Okay, it doesn't really matter. It hasn't updated here. It's not a huge deal. Okay, so for these, they're all going to the same group of 11 randomizer, minus tiling, which we can't group. So, 11 randomizer. For priority, I'm not honestly too concerned about this one. You can be if you want, but I don't really care for this one in terms of just setting that part up. I'm just going to move this on top of things. All right, so now if we go back, and this is set to false by default using this noise. And also, let's make sure this is in a category of, you know, I put this in different categories. Sometimes I have it in Albedo, sometimes I have it in global. I am going to put it in randomizer just so it's all together. So let's just take the original one here, pop over to the material instance of it, and just so we can see it happening live and close that out. Scroll down to section 11, use randomizer, and turn that on. And now you can see there's noise over it. And now let's just move this over to the other two to compare them. Now it's lighter than the other two, which is kind of expected. Turn that off. I guess it's always been lighter than the other two. Sorry, I have a new monitor, so I might be making color correction mistakes because I have not color calibrated this monitor yet. And clearly I have, because these are all 3 different shades now. But glad I brought it closer to that cube. It made it stand out to me more. So, hey, we now have a material that we can use to create materials using channel packed and non-channel packed textures, using different approaches to that channel packing, where we have control over how our PBR works, what PBR textures we're using. And for anyone interested, the total runtime of this recording is 2 hours and 5 minutes. I'll definitely be editing this down into multiple videos. All right, and probably doing new intros, by the way. Once again, this series has been brought to you by Patreon sponsors who picked the topic of me covering tech art. For my Patreon folks, before I finish the outro, I am so sorry that you're getting a 2-hour video. Whoops. This was a lot more detailed than I thought it was going to be. All right. So once again, this video series has been brought to you by my Patreon sponsors, and you too can have a voice on what content is covered in this channel by becoming a Patreon sponsor. Patreon sponsors will get early access to this video, either edited or unedited, depending on their tiers, or both, depending on their tiers, I guess, really. And their help has made this channel possible. And you too can help this channel out, and all you have to do is hit that like button if you've enjoyed setting up a material master that you can use for multiple sort of texture types and in multiple conditions, and that you can expand from. As I said, you can add rain and water overlays. I would show you an example, but I don't have one ready to go. I'll probably do that at some other future point. You can also add other things on top of it as well. And if you want to be here when the next video comes out, be it part of the Tech Art series, be it part of game development series in general, make sure to hit that subscribe and notify button. About 77% of my returning viewers are not subscribed. All right. And if you want to take your support even further, consider becoming one of those Patreon sponsors. All right. I hope you've enjoyed this tutorial. I look forward to seeing you in the next video, and I hope that you have a wonderful day.